Okay, so that takes care of confidence intervals. How about hypothesis testing? Once again, there's two ways of doing things with hypothesis testing. So let's first look at the normal approximation, namely using the central limit theorem. Now, suppose we want to test the hypothesis that the proportion is 0.082. Well, that's easy because now we can put that there, and we know n, and we have observed the proportion in the sample. And so, for example, suppose we had 0.115 was the proportion in the sample. Then we can calculate our z by putting 0.082, 0.082, 0.082 with a sample size 52. And the answer is take z equals 0.87, and we look that up in Stata, and we get that the p-value is 0.384. So that's easy to do. And in fact, we can get Stata to do all those calculations for us with this command PR test I. We had 52 observations, 6 successes. That's how we got the 0.115 as the proportion. And we're going to test the hypothesis about 0.082. And we actually put the count here. That's why the option count is there. Okay, and Stata comes back with this, which looks very much like, of course, the t-test and everything. So here's the answer. If you're doing a two-sided test, the p-value is 0.3802, which is what we had on the previous slide, roughly. Now, if you want to do a one-sided, there's the one-sided, and then here's the other one-sided. So that's using the normal approximation, which for large samples is perfectly fine. The other one you can, Stata has another option, which is called a bin test, and here's the immediate version of that. And so 52.6.082, just like before. And what it comes back with is the quote exact. So this is once again the exact version of this test of hypothesis. Now, exact is fine if you're doing a one-sided. So if you're doing the one-sided on the one side, the one-sided on the other side. What's controversial a little bit is how you do a two-sided test with an exact. And so this looks a little bit off here because the thing is not symmetric, especially when you're down here. So you would like to do the exact when you have very small numbers. 52 is way, way big. And once again, here's the confidence interval for the exact. And they really should put these in quotes. All right, so there are the options for you to do hypothesis testing.